Okay, we're going to talk about some special patterns in factoring. And we talked about these when we were multiplying. And so now we're going to talk about working backwards for factoring. And the first thing is what we call a perfect square trinomial. And a perfect square trinomial occurs when your first and last terms are perfect squares. And so if you don't know what a perfect square is a number that's been squared. So like 1 squared is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. 6 squared is 36. And then we've got 7, which is 49, and 8, which is 64, and 9 is 81, and 10 is 100. And then it just keeps on going. And this is something that's going to be really useful in geometry. And in fact, we'll kind of touch on it at the end of the school year, working with perfect squares again. But if you can recognize by looking at these that these are perfect squares, then you can check and see if it follows what we call the perfect square trinomial pattern. And you don't have to use this pattern. You can factor just like normal, and that's okay. So our perfect square trinomial, we look, yeah, 9's a perfect square, so this must be 3x and 3x. 4 is a perfect square, so this must be 2 and 2. And then we check to see if it fits the pattern, which is 2 times each one of those. So 2 times one of these and times one of these. So is this 12 really 2 times 3x, which is 6x, times 2, which is 12x? And it is, which means that it factors into a special pattern, which is this one. So that's a 3x is the root of the perfect square. So it'll factor into 3x, and then this, which is 2, positive 2, squared. And so it's useful because if you can notice that pattern of perfect squares, it makes your life a little bit more simple. So let's go ahead and check if these are perfect squares. And if so, we're going to factor them. If not, we're going to explain why they're not perfect squares. So let's look here. This is really 3x times 3x. This is really 8 times 8. And now I'm going to check my middle. So is this 2 times 3x times 8? And if it is, so let's see, 6x times 8, 6x, 6 times 8 would be 48. So is this 48x? No, it's not a 48x. And it doesn't matter if it's a negative or a positive here. I'll talk about it when it is. But if this is not a 48x, then no, not a perfect square trinomial. So we can't use our pattern. So we just have to factor it in another way. Okay, so let's look at the next problem. Okay, this is a perfect square, so this is a 9x times 9x. This is a perfect square, 5 times 5. So now I check the middle. So now 2 times 9x times 5, does that give me the 90x? So 2 times 9 is 18. 18 times 5 is 90. So that works out. Since it works out, that means it factors into 9x. And then this is where the sign comes into play. If this is a plus, this is a plus. If the middle is a minus, then this is a minus. So if this is plus, this is plus. If this is minus, then this is minus. So this is a 9x plus 5 squared. Now again, you could factor this out any way you want to. You could factor it out using the normal method, and that would be okay. But again, these are really big numbers, and so it may be harder to factor it out on your own rather than using this hint. Okay, so let's look at our next one. Let's see, x squared is perfect square because it's x times x. 49 is perfect square because it's 7 times 7. So now we check the middle. Is it 2 times x times 7? So is this 14x? Yes, it is, and it's a 14x with a minus. So that means that when we're factoring, it's going to be x and 7, and then because of the minus here, it's minus, and it's going to be squared. Okay, next one. So we look at the first, 36x squared, that's a 6x times 6x. 14, that's not a perfect square. Now, even though it's not a perfect square, you can still factor it. So we could still go ahead and multiply this out and still to try and factor. So 36 times 14 is 504. And then we want negative numbers because it has to add up to be a negative. Ooh, I don't think that's going to work. I think this is prime. I don't think this cannot. I think this can't be factored. I bet you if I make a list, there's going to be nothing that adds to be negative 10. Yeah, I'm not going to go through the list because it's just going to take too long, and I don't want this video to last all that long. Okay, next pattern. Now this is one that is extremely more helpful than the perfect squares. This is the difference of squares trinomial. And that means that when you're factoring, this is a perfect square and this is a perfect square, and in between it is a minus. So how does that factor? That factors into something we call conjugates, which means one's going to be the root plus the other root, and the other one's going to be the root minus the other root. Why root? Because the root is the base number before it's squared. So when I look at this, x squared is really x times x. 9 is really 3 times 3. So those are my roots. So this should factor into x plus 3 and x minus 3. So I use those same roots. One has a plus, one has a minus. And they have conjugates because when we multiply them out, that middle term purposely falls away. Okay, so let's look at this. My root is 2x because 2x times 2x is 4x squared. My root here is 1 because 1 times 1 is 1, which means this is going to factor into a 2x plus 1 and a 2x minus 1. Okay, let's look at our next one. 81 x to the 4th. So that's really 9x squared times 9x squared. 121 is really 11 times 11. So this is 9x squared plus 11 and 9x squared minus 11. And then I sometimes get people going, well, hey, well, isn't this a difference of squares pattern too? And I'd say, yes, this is a square, but this is not a perfect square, so really I can't. Okay, so let's move to our next one, y to the 6th. Well, that's really y to the 3rd times y to the 3rd. 169 is really 13 times 13. So that means this is going to factor into y to the 3rd plus 13 times y to the 3rd minus 13. Now, do you have to do this? No. Is there another way you can factor it? Well, you can factor it normal. So, for example, let's look at the 4x squared minus 1. Well, it doesn't have a middle term. So I could rewrite this as 4x squared plus no x minus 1. And then I can multiply first and last. So negative 4x squared. And I make my list, negative 1x and 4x, negative 2x and 2x, 1x and negative 4x. And then what adds to be nothing? What makes those x's cancel out? And that'll be the negative 2x and positive 2x. So this becomes 4x squared minus 2x plus 2x minus 1. I pull out my common factor. Pull out my common factor. So this becomes 2x times 2x minus 1. Oops, didn't mean to write that. Then I pull out that 1, and that leaves me with 2x minus 1. Since they both have a 2x minus 1 in common, I factor that out, leaving me with a 2x plus 1, which perfectly matches this answer up here. So again, you can go through all of this, but these are shortcuts that we see that we want you to be able to use to help you save time.